So in this example, what we're going to do, we're going to integrate trig functions and exponential functions. Now they're really simple. The argument of the sine and the cosine function is simply x, and the power, or the exponent, on the exponential function is simply x as well. So these are really basic functions, and we'll do them now. So we're going to have the integral of 7 sine x plus 5 cosine x minus 2/3 of e to the x dx. Well, that's going to be equal to, now, the rules here, basic rules we use are the integral of sine x dx is equal to minus cosine x plus c. The integral of cosine x dx is equal to positive sine x plus c. And the integral of e to the power of x dx is simply equal to e to the power of x plus c. Okay, so adapting those, that's going to give us, so we can do this integration in one line. We get rid of that. We're going to do the integration altogether. So 7 sine x, well, we're going to keep the 7. If you integrate sine x, you get negative cosine x, plus 5 times the integral of cosine x, which is sine x, and then minus 2/3 by the integral of e to the x, which is e to the x. And then we just use 1 plus c after all of them. Rather than using a plus c after every individual part, we just put a single plus c at the end. Because if we add these three constants, c over here on the right hand side, c and c, if we add those three constants, we just get another constant. I'm not sure quite what happened there, but I think we're back to normal. So the c that we finally end up with is just the sum of all these individual constants. We don't know what any of them are, so the answer is simply going to be another constant. Now we obviously will tidy this up a little bit, and we write our answer is negative 7 cosine x plus 5 sine x minus 2/3 e to the x plus c. So in every case, what we did was we kept the constant that was involved in multiplication, so 7 sine x. We would keep the 7 and integrate the sine x, keep the 5 and integrate the cosine x, keep the negative 2/3 and integrate e to the x. And this is our final answer here. Okay, that was a quick one. Thank you.